Like integration by parts. So let's see if you can figure out when I write this down how this is like integration by parts. Summation by parts is quite cool. It says if you have sequences like a n, b n, well, let's let big A sub n be partial sums of a sub k, where k goes from 0 to n. Can't stop me from defining that. Okay, and this is defined for n bigger than 0. But just to make my formula work out, I'm going to set a sub minus 1 equal to 0. Okay, so I may need to refer to a subscript that's a minus 1, okay, just to make the formula work out. Then, something very amazing is true. If I want to sum a n, b n, let's say going from P to Q. And if you don't mind, I'm going to just not write the index here. I'll just write the P and Q, so from now on, because it's clear what the index is. The claim is this is the same as, check this out, the sum of big A sub n, little b sub n minus little b sub n plus 1. And here n goes from P almost to Q is Q minus 1. I guess I will write the n here so you know that's the index. Plus, okay, a sub q, little b sub q, minus a sub p minus 1, little b sub p. Somebody tell me how this is like integration by parts. What are some general features of this formula that remind you of integration by parts? Integration by parts says something loosely like you want to integrate u dv, then that's uv minus integral of v du. Integrals are like sums. Yeah? You'll learn that more in Math 132, actually, but integrals are like sums. Okay. So if I want to integrate u dv, what's playing the role of u here, and what's playing the role of dv? Anybody see this? Bonnie? Is it? What's playing the role of the integrals here? Integral, yes. Okay, good. Good. What's playing the role of u? There's a u and a dv, and you want to, something from here, dv from here should correspond to something like v here. So what's playing the role of dv and v? A, yes. A, big A is playing the role of u. And if you let big A be the partial sums, then the change in big A is little a at every step, right? So what's playing the role of big A is kind of like u. And so then du, sorry, big A, yes. Integral of u, integral of, sorry, I mean v. Big A is playing the role of v. Then dv is like little a, right? Okay. And then what's playing the role of u? U dv, that's b, right? B is playing the role of u. And what's playing the role of db? du. It's this change here, right? So what we have is this is like the integral of dv u is the integral of v du, that's this part, minus what? uv, or vu. Yes? Now, why do I have two terms here? Yes, you got to evaluate the endpoints. There's a P, there's a Q, there's a P. Okay, this is not quite the same. There's a -1 there. But this is going from, okay, something P-like to something Q-like. It's not quite there, okay? But it's close, right? So maybe I'll circle this a little bit. It's just a little bit off, right? Okay, but in the limit, yes, these are exactly the same concept. Let me show you why summation by parts holds, and this actually would give you a visual interpretation of integration by parts in the discrete case. Actually, as you'll learn in Math 132, summation is actually integration with respect to a certain integrator. So summation actually can be thought of as a special case of integration where you're integrating over a discrete set. Okay, that's amazing. That's cool. But here, this is where the proof comes from. Proof. Idea. By the way, the proof is not hard. You just write out everything. Okay, if you write out everything, you can verify both sides are equal. Okay, so the algebraic proof gives no insight whatsoever. This is the geometric proof. The geometric proof is this. It's not what. See, imagine a square. You're going to love this. This is so cool. Jinjing's like, yeah, I want to see this. Okay, here we go. Look, imagine a square that's broken up into little pieces here. Like, how about there's a little length here, A1, little length here, A2, little length here, A3. Yes, you with me? Little length here, A4. I'll just do 4 little chunks. Okay? Now, imagine the B's. Here's a little length B1. Now, the B2 is actually the whole length here from the bottom to this point. That's B2. Let's make this B3. And let's make this B4. With me? Yeah? Oh, this is so cool. Watch. What is the sum AN, BN? It's adding up these areas, isn't it? The sum of A and Bn is the following. This is the first thing in the sum, this area, yes? This is the second thing in the sum. Yes? Yes? This is the third thing in the sum. This is just going to blow your mind when you see this. This is the fourth thing in the sum. I want the sum of these areas. Integration by parts says, just take the total area of the box and subtract off the sum of these areas. Right? The integral of u dv, these are the little dv's. Of course, I think I have my a's and b's switched, but oh well. No, I think that's fine. That's right. This is dv. The integral of u dv is uv minus the integral of v du. Right? That's integration by parts. That's summation by parts. Okay? Isn't that cool? Now, of course, you can also see why there's a little offset here with these coefficients, right? The p and the q minus 1.